So what we're going to do is we're going to just do two of these together. The first one we'll do a little bit more step by step. And then the second one I'm going to ask you to try to do entirely on your own, and then we'll just check it. So, and that's it. There's no work with this, like I said, no work associated with this lesson. If you want more practice, then make sure you've done all the work from yesterday, okay? Or use that applet that I posted, the GeoGebra applet. There's lots more practice in there, almost infinite practice. Or if you still really want more, I mean, there will be unit review. Or, you know, you could ask me for more work, but I doubt that that's what anybody wants is more work because it's already enough as it is. So hopefully we had a fairly good amount of practice yesterday, and hopefully that was enough. So we're going to do two questions here, and the instructions are the same. Sketch one cycle of each of the following with the transformations and the key properties like we talked about. And again, there's kind of the step-by-step process outlined here. We start by looking at the amplitude in the zero line, and that gives us the max and the min, and we know that important things happen at the max and the min. Those are some of our key points. Both sine and cosine have 5 key points that you need to know, right? You need to know where they are. And then the horizontal shift tells you where horizontally, what x value to put the first point, and then you probably are going to count squares to find each point after that. And consider whether you have a reflection. Make sure you consider whether it's sine or cosine and all those details. And we were doing kind of a step-by-step process, doing it in the same order every time. Doing things in the same order every time is a really good idea because it takes a load off your brain, believe it or not, when you're actually doing it on a test because you're in a habit of just doing it a certain way and you don't even have to think about it. So those kinds of habits can really help watch for little mistakes that you would make on a test, help you move faster on a test, all those kinds of things. So habits are good. And my habit that I started yesterday and everybody was kind of following is I always start with the zero line. Oh, actually I missed something, didn't I? What did I miss? Yeah, we write out the A value, the C value, and the D value. So let's do that. So A, C, and D. And you can try that if you want. Don't wait for me. Some of you have probably already done it.
The C value is positive when coming in. Do we keep it at positive or do we switch it to negative?
You switch it. So do you switch the C value? We know that plus 120 is a shift to the left, right? That's something that we definitely know. But people often wonder, what about the C value? Now, in the end, it doesn't really necessarily matter. When you graph, you have to make sure that if it's x plus 120, that you're doing a shift to the left. But it actually does also mean that the C value is negative 120. So the C value also switches signs. And you can remember that because it's y equals a cos x minus c plus d. So if I put negative 120 in for minus c, 2 negatives makes a positive, and that's what actually flips the sign. Okay, but yeah, so that's good. And A is negative 3, and D is negative 0.5. So we've got every kind of transformation that we did yesterday. The practice only had a couple of like this, but here's one more that we're going to do. All right, now we got our zero line, and our zero line is, so again, go ahead and write that quickly if you want to try on your own. The zero line comes from the D value. Step 2, amplitude. This is the tricky one. A few people were caught by this yesterday. Amplitude is always positive. So it does come from the A value, but we drop the negative. And then we use those. This is the key. We need the zero line to graph because some of the important points happen on the zero line. But we need the amplitude to find the max and the min because some of the important points happen at the max and the min. So watch this. The max is the 0 line. You start with the 0 line for both. For the max, you're adding the amplitude. For the min, you're subtracting the amplitude. Now, what catches some people is if you think the amplitude is negative, then you're adding -3 or subtracting -3, okay? And you end up with your max and your min backwards. And your max is actually lower than your min. Now, if you realize that and you graph it properly, again, you're probably not going to lose marks. But it starts to confuse people, and they start to put the points in the wrong place. I saw that happening. So the best thing you can do is try to remember that the amplitude's always positive, and then hopefully you won't have that problem. So this works out to 2.5, and this works out to -3.5. It's amazing how just having a decimal in there can be tricky. So use your calculator. Watch, -0.5 minus 3. And get the decimal version, -3.5. Like, if you're making mistakes with the negatives or fractions, it's worth it to do it on your calculator and make sure you get the right answer. Okay, number 3 is the... So not only do you have to know how to do all these, but you kind of need to know what they are. Don't necessarily have to be done in a particular order, but like I said, habits are good. But if you didn't know what to do next, you'd be stuck. So number 3 is the start. See if you can figure out what that is. And it comes from the C value, right? So -120. Number 4 is the period. And we, in this course, are not changing the period, so it's always 360. Now, in the next lesson, we're going to actually talk about that. We're not going to be graphing in the next lesson, but we are going to talk about what it would look like to change the period, because that's going to help us with applications. But for graphing, our period will always be 360. And then number 5 is, again, not necessary. If you don't show number 4 and 5, but your graph is correct, you will get full marks. Number 5 is a useful check. When we have a shift, we're not going to end at 360. Our cycle length is still 360, but we're going to end somewhere else because I started somewhere else. So number 5 is the end, and it's the start plus the period. And -120 plus 360 is 240. Everybody good with that? This is what I always say is, like, that's the hard part. The hard part's done. Now, when I say that, that doesn't mean that everybody's going to be flying through the graphs. I know that it takes some practice and some time to figure out how the graph works. But once you get it, that is the hard part. Once you get how to take this and put it into the graph, you've done all the work, and where all the points go is done. So we're going to do 2 more quick things before we actually graph. And I'm going to zoom in on the equation here, and I'm going to look at 2 things. I see there's a reflection. That's easy to forget because it's not in these details. So I want to look back at that. And then I also am reminding myself that it's cosine. And again, every year, a few people, and I noticed this yesterday, that like as you're practicing, your work is fantastic, your graph in every other way is correct, but the question was actually sine and you drew cosine, or vice versa. And that's probably because the last question was sine and that's what you had on your mind, or who knows what. But that happens to all of us. Like I said yesterday, it even happens to me. And so I try to be in this habit that I always look back to see if there's a reflection and to double check which of the 2 I'm supposed to actually be graphing. Of course, we have to know if it's cosine or sine, because they look a little bit different. So we have to know which one it is. So it is cosine, and it is a reflection. The base curve for cosine, this is something you need to know, starts at the max, right? That's where it starts. This is the progression you need to know. Max, zero line, min, zero line, max. That's what cosine does. If it's flipped with the reflection, then it's going to be the opposite. You're going to start at a min, zero line, max, zero line, min. And again, that's just something you need to know. Okay? We're not figuring that out along the way. That's part of our knowledge that we have now. So when I say the graphing part is easy, it's easy if you know that fact. And now I know I'm cosine. I'm starting at the min. Well, I know what the min is. And I noticed this too as well, talking to a few of you yesterday, that when I asked the question, well, where does it start? And you don't know if I'm saying, well, starts at the min. Okay, yes, but it also starts here, right? There's two places that it starts, quote unquote, starts. And you got to consider both of those. So we're starting at negative 120 and negative 3.5 because we're starting at the min. So negative 120 and negative 3.5. Well, negative 3.5 is here. So I'm going to do a line there just for now. Normally I wouldn't do that. But I want to talk about the scale. So sometimes, and the other lessons that we're going to do today are definitely like this, where every graph it might have a bit of a different scale. So one of the things you have to do is look at what the scale is and what it's counting by. So if I go 1, 2, 3 squares to 90, 90 divided by 3 is 30. Every square is counting by 30. I have to figure out where 120 is. So 30, 60, 90, 120. So it's the fourth. So my first point goes there. I know I'm explaining a lot of this is all my internal thinking, and hopefully it happens fast, but all those details you need to be thinking of when you are doing it. Where does it start vertically? And in this case, it's the minimum. Where does it start horizontally? And in this case, it was negative 120. Then I go to the zero line, and again, I've already written that down, so I just glance back up and I see the zero line is at negative 0.5. And yesterday we were drawing that in. That's a really good idea to do it. 1, 2, 3 squares to the zero line. Then I'm going to the max, which again I've got written down. It's 2.5. 1, 2, 3 squares up to 2.5. Cosine now goes back to the zero line. 1, 2, 3 squares. Then back to the minimum because it ends on the minimum because it's got a reflection. 1, 2, 3 squares. And then the last thing that I do probably before I draw the curve is I'm going to follow this up and sort of check. What value is that? Well, it's 1 square back from 270 or 30 back from 270, which is 240, which is where we were supposed to end. So I think I've done it correctly. If you miss, you've got to have 5 points. If you miss one of the 5 points, you're not going to end at the right spot. Or if you only count 2 squares by accident, you're not going to end at the right spot. So that's why that can be a good check to go through. Remember, this has to curve, not be straight corners. And there you have it. Everybody happy with that one? Okay, so whoops. Okay. So I want you to do this one on your own. If you're watching this at home, I would say pause the video and do it. The solution's going to pop up quickly here. And same for you. I'm going to pause the screen and you won't see the solution pop up, but it'll pop right up. And you do it. I'll walk around and check how it's going, see if anybody has any questions. This is the only one you get to do on your own for practice. That's sort of new from today, okay? So we'll try this, and in a few minutes we'll come back and check our answer, and I'll go over it much more quickly than we did the last one, but then that'll be that. There it is. So if I zoom in here I've written out my A, my C, and my D. Again, the C changed from being x plus 210. That means it's negative 210. We've got to shift up 1, so D is 1. And my amplitude is positive this time, no reflection, and it's 1.5. Now we start writing out the details. First thing we want to do is zero line, y equals 1. Next thing is amplitude, which is the A value, and you drop the negative if there is one. In this case, there isn't, so it's 1.5. And then this is the trick, is it's the zero line plus the amplitude, the zero line minus the amplitude, right? And I just have to make sure I do the math right. I could see some people getting the wrong minimum, getting positive 0.5 or negative 1.5 or something like that. If you're trying to do it in your head, this is what I've said a few times. If you're doing integer math in your head and making mistakes, especially if you have decimals, maybe try your calculator because you don't want to get that mistake. I'm going to talk more about that in a moment. Okay, so we're going to come back to that. Those are the first two steps. Step 3 is your start. So that's your C value. Again, adding 210 means a shift to the left, 210, so my start has to be negative 210. Our period for us is always 360, and the end is the start plus the period, and that works out to 150. And that's the hard work done, hopefully. Sine starts on the zero line, which is 1, and it starts at 210, which is here, 30 past negative 180. Then sine goes to the max, and these are the things you need to know. We talked about cosine already. Cosine goes max, zero line, min, zero line, max. Sine, you have to know this one, zero line max, zero line min, zero line. That's just stuff we need to know. So when I got my start, then I know I go up to the max next, and for us, because I'm giving you the grids, and we're using the same scale every time, it's always 3 squares, okay? And I definitely wouldn't change that for the test. That would be incredibly nasty. Then I go back to the zero line, 3 more squares. Then I go to the minimum, 3 more squares. Then I go back to the zero line, 3 more squares. And a couple people were wondering, were like they knew it started on the zero line, not sure where to go next. Well, you know that hopefully you've seen enough of these that you know that this is what a sine curve looks like. So just draw it. Right? Draw it off to the side, scrap paper or in the margin and say, oh, well, it goes up to the max. Like that's where it goes, right? And you probably know that cosine kind of looks like that. So if you draw a little sketch off to the side, you say, well, it starts at the max, goes through the zero line to the min, back through the zero line to the max. And of course, you have to think of whether you are reflecting it or not, okay? And then there you have your graph. Now, when you're done your graph, you can check to make sure that you ended where you were supposed to end, which was 150, and that is 150, so that's good. The other thing you want to look at, and this has come up several times, always does, is from your zero line, there's 2 things that you can look at. Is it equal distance to the top and to the bottom? Because if you did some of your integer math incorrectly for the max and the min, and then you followed that max and min to graph, it might not look like this, and it always has to. The max and the min are equal distance from the zero line. That's what the zero line means. Okay, so that has to happen. So once you've graphed, sit back and ask yourself, does this look right? And then the other thing is, there has to be equal distance between each of the points. And for us, it's always 3 squares. In other courses or in other situations, that's not a solid fact. You could certainly do other scales and have other things where it's not 3 squares. But for us, for graphing, it's always 3 squares. So you can double check. If I didn't do 3 squares, it might look like this. That looks very different from the sine curves we're drawing. It's not, this doesn't have the same symmetry. That's what will hopefully allow you to catch the fact that you made a mistake. Or what if I did this for whatever reason? That's not what these look like. So we do have to practice enough, and we're going to see a bunch more graphs of them today. We want to practice enough to know what these look like and get familiar with them, just like a parabola. You need to get used to what a parabola looks like and that helps you draw them better. Any questions? I love to see the progression, and I don't know if you noticed, but yesterday when you were working on this, there was a lot of uncertainty, not sure what to do. This is really weird. This is really new. And, you know, by the end of the day, people were getting on it, but it was amazing to see you coming in this morning and like just going, you know, and there might have still been a couple places where you hesitated, you weren't quite sure, but basically everybody was able to get 1, 2, 3, 4, 5. You're just doing it, right? So like that's a lot of progression in a really short amount of time. And that coming from the practice that you're doing and thinking about these things that we're supposed to think about. So it's fantastic.